Here we are with Matt.
Well, good morning, everyone. Thanks for the opportunity to speak a little bit about Burning Man. Originally, the talk was focused on automation, but as the presentation got reviewed by the program committee and I did a few dry runs, it really covers a lot about technology, the design, and a lot of the layer 8 and layer 1 issues. So it's a very broad talk that does include some examples of the automation framework that we use, but it's not focused entirely on that. Again, at the last NANOG, as Greg and others have mentioned, we had over 850 attendees, and that's pretty significant numbers. And I don't necessarily know everyone in the audience, and at least when I'm on the other side of the podium, I like to know who's talking. So not everyone knows my background. Worked at an AS that specialized in delivering animated GIFs and cat pictures. I've done some amateur appearing. I've also helped send and receive money, sometimes using that money for amateur reasons, and of course, some community projects. So the background is definitely a mixture of content, ISP kind of carrier, and everything kind of in the middle. But I also have a day job, and that's with a 5-digit AS. You may know that as a startup. That company is called Cumulus Networks, and I work in the office of the CTO. And essentially, I bring the background of actually operating networks from both kind of a system administration perspective and a network operator perspective. And we have a product that is basically an unencumbered Linux operating system. And I'm not here to talk about Cumulus Linux or Cumulus, but in my job, typically what I get asked every 2 or 3 days from customers is, well, what's this SDN thing? Or how do we get some of that OpenFlow? Or NetDevOps or DevOps seems really cool. We want to have some of that. And there's a lot of buzzwords going around the industry. And what I've always told people, whether it's a customer, a partner, or a friend, is that if you can build a network in the desert that has extreme conditions applied against it, both for making it operate and for the personnel operating the network itself, these are folks that may be dehydrated, they're volunteers, they may be distracted. If you can learn from those lessons, then you can apply it to your own organization. Because again, a lot of times when you're thinking of SDN, DevOps, OpenFlow, a lot of that comes down to process and procedures. Most people don't want to invent their own routing protocols. They're interested in just keeping things simple, automating, and moving forward. So I think Burning Man is a good snapshot into applying some of those approaches. To talk a little bit about the event itself and the physical location. So this is held in northern Nevada. It's about 2.5 hours outside of Reno. So it's northeast of Reno, which is the Lake Tahoe region, if you're familiar, for some of the skiers or outdoor activity enthusiasts in the audience. And it's roughly around 70,000 people that attend the event. It's held on a dry lake bed known as the Playa. It's the Black Rock Desert, and so the city name is typically referred to as Black Rock City. It's been described as a social experiment or a festival or a party. I don't feel qualified to represent exactly what Burning Man is. It's something it's something different for everyone else. I've had friends summarize it as basically the city of San Francisco transplants to the desert for a week, and I think that's a good snapshot. So the good and bad things you could imagine of an urban city transported to a rural environment. That's kind of what happens with Burning Man. It's one of the largest Leave No Trace events. So what that means is that there's zero infrastructure before the event. We have about 3 weeks to set up. There's the week of the event itself. It's typically held around Labor Day. And then we have 3 weeks after the event to wrap up. And because it's a Leave No Trace event, that means no trash is allowed to be left on the site. And that's everything down to a gum wrapper or an oil spill. It's not permitted. It's held on federal land, BLM land. Burning Man provides basically basic life safety services, if you will. So that's things like porta potties, medical care, and what I like to call guardrails. So a guardrail is things like mutual aid, like law enforcement. They have ice available for purchase, kind of basic necessities. But everything else you have to provide. So that includes your own water, your own food, your own shelter at a minimum, let alone your own IP or whatever other infrastructure you want to bring out there. everyone sees a city in a different way. For me, I see Burning Man as this diagram, as a network diagram. Everyone has a different view of what a city looks like. Sometimes that's a particular attribute, maybe the Eiffel Tower or the Golden Gate Bridge. Sometimes it's the street layout. For me, it's the topology. So we'll talk a little bit about quickly the history of technology at the event, and then how we've scoped up or scaled up the IP network over the last couple of years. So in the beginning, around the mid-90s, we had some connectivity well before I was attending. This was using old 900 megahertz DEC equipment that was proprietary, and they basically just took a dial-up modem and shot it out to the desert. Bruno's is the local motel that's in Gerlach. It's the only motel within roughly 100 miles, so there's not a lot of choices there. And that was kind of the beginning of some limited internet connectivity. When I started to attend was the late 90s, and so at that point we were using different technologies. Originally we started off using ricochet modems. Ricochet modems, a lot of folks don't know, they actually have a mode where they can talk to each other without the repeaters. They were quite interesting because they were 900 megahertz 1-watt modems, so you could literally be in one RV to another and it just worked. And so at that point we didn't really have to learn anything about RF engineering. It was just basically standard PPP networking. Over time we've had to learn a lot more about how antennas work and link budgets and that sort of thing. Today it's fed by a local wireless ISP. He's again roughly the only carrier available within about 100 miles. So there's not a lot of opportunities for additional connectivity there. There are some T1 circuits. Those are also shot via microwave. That phone company was previously called Nevada Bell. It's now a subsidiary of AT&T. They have 4 slots for T1s. They're all taken by the county and other organizations in town, so that's not even an option for us. There's also no cable. So traditionally we were using satellite connectivity, and then in the last couple of years it's been a terrestrial wireless ISP. And I want to point out here that obviously those numbers are not impressive for this audience on a purely bandwidth standpoint. Most of us have that amount of connectivity to our handheld or in our home, but it's impressive because of the location and some of the deployment characteristics that I'll walk through here. In the 90s, Burning Man really saw technology as something that they weren't really hip to. The event was started by artists, and so their background was kind of liberating themselves from, at that time, was kind of multimedia gulch and the .com that was being built in the Bay Area at that point. So they wanted kind of an escape from that, and they were expecting, or rather, they were experiencing a lot of kind of NIMBYisms, meaning they don't want a lot of these art projects in their own backyard. So that's actually why they started this event, is to be able to bring their art and their culture to somewhere where it was welcomed, the middle of nowhere, where there's not a lot of competition versus, say, San Francisco or Baker Beach. And so their use of applications was traditionally limited to looking at weather. When you have a populace at that point of 10 to 20,000, a weather event is fairly significant. Like if it rains, people are stuck because they can't walk, they can't drive. If that happens for several days, people may not have brought enough food. They have to pump the porta potties more often, that sort of thing. So weather is very important for the organization, has been pretty much since day one. They were also producing a newsletter at that point. So their use case for internet was they wanted to be able to email a PDF to Reno, pick up some newspapers and bring them back and have them printed out. And that was it. It was really limited towards those basic use cases. The participants that actually attend the event, these are the 99%, if you will, they had a number of interesting projects. So a lot of people, when they think of Burning Man, it's art cars or parties or raves or grilled cheese or whatever. Everyone brings a different contribution. So in my example, I'm not really good at welding, and I'm not an artist, but I build networks. And so we began a project called PlyNet, and PlyNet is, or was at that point, basically internally focused network. So it had the predecessor of a wiki, where we had a directory of camps that anyone could add the name of their camp and location. It had an early version of Twitter, which was basically just an IRC client and a Next terminal. Really basic stuff that's all very commonplace to a lot of the youth and young adults would just expect in a network. We were placing there in the late 90s. Video streaming was a very interesting application. So if folks remember things like Real Video and some of the earlier video streaming protocols, that was stuff that was being used out there in the early 2000s. And so basically you had these two different use cases. Some of the citizens, the participants, utilizing the internet for their art projects or their contributions to the community, and then the actual organizers that were using the network for either internal purposes or for external communications. So again, this is very different than a lot of the other events you might have heard of. For example, there's these European hacker camps that are quite popular. Those typically you can get 10 gigabits to your tent. That's not the type of event like Burning Man. So the IP network is basically a utility here. It's not the focus of the event. So I took a break. I took roughly 5 years off. A number of folks tend to do this. You get burnt out. It requires potentially several $1,000s to go drive out in the desert and build a camp and have a fun time. So it's easier to do other projects. And so at the time I was building essentially my career and meeting folks like Tony Capello that attends NANOG, and we were discussing things like community wireless networks and getting more educated on basically wireless engineering. So again, it was a time of transition where IP network engineers were learning kind of the background of RF and vice versa. So it was a very interesting time in the early 2000s there. The network continued to grow pretty substantially during the time that I had left. So we had more customers and more bandwidth that came up, and the use case of the network changed dramatically from when I returned. There were several departments that Burning Man has internally. One of the most popular and most critical is an organization called ESD, or the Emergency Services Department. They actually have an on-site hospital vendor, and this is a very interesting use case where when people would have accidents, they had a lot of personnel available. They have a full pharmacy available on site, but things like x-rays were a real challenge, and so they'd have to put someone in an ambulance, drive them 2 hours to Reno, get the x-ray for several hours, waiting for that, and then come back to the event. So it was a pretty expensive use case there. They were able to find a vendor that does a remote x-ray technology, so they bring an x-ray machine on site, they take the x-ray, they send the results over the network to remote personnel that then read those readings. They do that for other hospital applications too. We also serve as the PSAP for the region. This is something that the FCC gentleman will be aware of. PSAP is a public safety answering point. It's essentially where your 911 calls go to. So for ESD, the network is very critical. They also run their own two-way radio system. So we have a number of those Motorola radios like you would see from a police department. So that's some of their major functions that we overlap with. The city has its own DPW, Department of Public Works. So these are volunteers that build the city. So this is everything from a shade structure to signage to basic plumbing, like building the fence around the event, that sort of thing. They have a number of subsidiary departments. One that we work with pretty heavily is called Heavy Machinery. They have an entire power department. Power there is pretty substantial. Typically, by the math that I've seen over the last couple of years, you're seeing roughly about 1.5 megawatts of power at the site. So there are a number of generator systems that folks bring out. For the organizations, those are fed from the large semi trucks of generators. And at a lot of the camps, they'll bring out like a 75 or a 50 kW generator. That's not unheard of. Those are very popular out there. As you can see, the applications have grown pretty substantially. A lot of them have moved to cloud-based applications. So in the mid-2000s, it was very popular for organizations to have their own MySQL server or their own FileMaker server on site. Some of that has moved to cloud-based applications, particularly around personnel management, so like shift scheduling, that sort of thing. Again, public safety is a strong component of the event, so they have their own FM station that broadcasts public safety information, like for example, the city rained early on Monday this year, and so they were giving guidelines around folks to not leave their camp and to stay calm, and that the sun will come up and it will dry and it'll be fine, and that was the case. So they use that for streaming out to folks. And again, other departments. There is a DMV at Burning Man. It's not called the Department of Motor Vehicles, it's the Department of Mutant Vehicles. So DMV actually registers art cars. So art cars get a license for a daytime or nighttime operation. They have to have various signage, lighting, the driver has to be sober, etc. So they have pretty strict definitions there. They're yet another customer to the network. Commissary, you have thousands of volunteers you have to feed. That volunteer populace is very dynamic, so they place an order with their food vendor every day, and multiple semi-trucks come in and out with that food and beverage. Ticketing is also really important. Ticketing is all done in the cloud, but we have multiple egresses of ticketing. We have a main gate, we have a gate next to the airport. The airport has its own FAA designation, right? So it's a real city. It's not just a festival in the middle of nowhere. It's an actual functioning city. So some visuals here that might be interesting. ESD, they have a number of compounds or buildings that they form. As you can see here, the large antenna towers where they put their trunked radio system, their two-way system. The other portable room towards the left side there is their dispatch center, so they have a number of consoles. Again, just like you would have in any normal city. All of their equipment, they actually stage in Reno and work on it year-round, get it tuned. And then during event time, they come out a few weeks before and just bring out all the racks, recable it, and power it back on. One of the departments I mentioned, heavy machinery, has a number of, as you can imagine, heavy machines to operate. So these are things like scissor lifts, boom lifts, forklifts, heisters, light towers, forklifts, you name it, lots of lifts. Typically, these can do anywhere from a couple, 100 pounds to usually up to 50,000 pounds. So a lot of art and infrastructure requires this machinery to operate, and we're very thankful that they have the boom lift so that we don't have to climb 60-foot towers. They can just point us up in the tower and we can aim our equipment. So the department that runs this infrastructure is called the ITS group, or the Information Technology Services group, and so we're essentially the IT department for the entire organization. So we're serving those departments like the DMV, Arctica, Media Mecca, Cafe, that sort of thing. Some of the larger departments like ESD or Rangers have their own IT staff, but overall we're kind of the folks people come to. And this again can be anything from my printer's not working or my database is corrupted to I need more bandwidth or I need static IPs. So it's pretty varied. A lot of folks assume that we sit in an air-conditioned room all week and it's really a luxury style event for us. That's just not the case. And it hasn't been for several years. So a lot of new volunteers are kind of shocked if they assume, oh, we just get to sit in like a data center equivalent. And while we do have rooms that are air conditioned and comfortable, most of our time is spent, particularly at layer 1 and 8. So there's a lot of physical attributes we have to do. Putting in grounding rods. It's not like a colo where there's a grounding bus. You have to build the bus, right? You have to get the IP, which means you have to get the power there. The power is not there because that's another department. Okay, now you've got the power there, you need to do the trenching. Well, you don't operate the ditch switch, for example. That's another department. So there's a lot of time spent organizing, getting this infrastructure built. It's not just us doing these installations guerrilla. So when I came back to the event, I kind of focused on some of the lessons I had learned essentially in the real world. And I think a lot of this can be based off of kind of traditional either Six Sigma or Toyota lean manufacturing or kind of whatever you want to call it. But it's essentially this process of observing kind of the initial state of how the team is functioning and then revising that with some changes and then revisiting that. So it's a kind of a constant agile approach of how do we make things better incrementally. So when I came back, a lot of these departments were being served with a network that had a lot of problems with it. We had a large layer 2 infrastructure. Part of that was due to the equipment that we had. It wasn't well funded, so it was literally old Linux PCs or BSD PCs with a 200 milliwatt card. And that was great for community wireless network, but not a network that had to act in kind of a carrier grade fashion. NAT was becoming a problem as more departments started to run applications. We had effectively 2 different business units. We had kind of this legacy, these are the participants that kind of built their own thing, and then we have these departments which seem to be growing and growing and wanted to run more applications. So we were serving these 2 different end users pretty differently on both the service we were delivering them and the approach in terms of the management delivering them that service. A lot of configuration was manual, so you had that kind of typical tribal knowledge effect, which is very detrimental to a lot of organizations, especially when you're trying to bring new volunteers on every year or there's turnover. Monitoring was obviously a big problem. Single points of failure are a particular issue for us. Power we don't necessarily control. Power outages do happen. Tanks don't necessarily get refilled. If it rains and they can't deliver the gas, for example. If there's a physical issue where the tower gets run over whatever the case may be, there's a lot of times where we can't make everything as redundant as we'd like to. And I think most importantly is staff burnout. All the folks that run the network are volunteers, so we're there to attend the event, and it doesn't make sense if we're going to build this network and then have to work during the week of the event. So that was something that I tried to address as soon as we could. So we looked at this in a couple different ways. One is, by creating a unified team, it was really helpful for us, particularly on the RF side. We were starting to run out of spectrum. Most of the links we were using were unlicensed, and so to be able to coordinate that was really helpful. We actually hold an event every year in San Francisco where we invite any RF users of Burning Man to participate. So this is typically folks for art projects. Zigbees were really popular about 2 years ago. Drones are the new popular thing. So we try to coordinate with other large users of spectrum, regardless if it's licensed or unlicensed, just so that we can have some visibility into that. Other main thing is coordinating IP addresses. As you can imagine, getting a lot of your own unique IP space for a temporary event is not easy, and so we had a lot of layers of NAT, so coordinating the usage of NAT was very important. For me, I think one of the things that I found challenging was that we had a number of technologies in place that were hand-built. So, we had the Socris boards, and we had the homemade, Debian boxes and whatnot. And that was great because it was only a couple $100 and applied really well for kind of homemade networks, but it wasn't really scalable for a team that had knowledge that was more mainstream. So we wanted it to be basically anyone off the street can be applicable to managing the network. So we bought what my father would like to call COTS equipment, or commercial off-the-shelf equipment. So stuff that you could escalate to. You could download a user manual, you could call an 800 number, anything you would normally have. And then we standardized the service offering. So we wanted to be very consistent in what we were offering. So for departments, it's always a wired gig E. They have no idea what the actual transport mechanism is. And then for participants, we do kind of a self-install provisioning. So again, a lot of layer 2 previously, so we made a rule that we're going to route always. If you want large layer 2 between two diverse locations in the playa, you have to tunnel it or VPN it yourself. We don't provide that. It's fully routed. We only do NAT in the town where the link demarcates, so there's no NAT on playa. So any department or any participant can route between each other. We continue to do segmentation as much as we can. So for example, we'll run a VLAN trunk to an access point, and then each station will listen to a particular VLAN tag. So as best as we can, we try to segment as much as we can with the equipment we have available. And then on the automation front, we started initially with routers and switches, and then we grew over time. This didn't happen overnight. Over several years, we've increased the automation framework. And I think that really came home this past year, where one of our volunteers who's actually here at NANOG, Ralph Mullen, if Ralph can stand up here for a second here. Ralph did the presentation at the last NANOG about some of his telemetry that he does in an archive, but he also is one of the main volunteers for the network at Burning Man. And I think he made a really good quote where he was able to come to the event a couple days before everyone else and immediately be effective, because the automation framework was very useful. He could just jump in and start going. He didn't have to get a bunch of training time. So we, on the participant side, basically formulated kind of a ghetto DOCSIS, if you will. One of the things that's interesting about Ubiquiti equipment is that it ships looking for a station, looking for an access point. So it's configured as a station from the factory. It looks for an access point called UBNT. So conveniently, we beacon an access point called UBNT. And because it's in factory default state, we know what the credentials are, so we can log into it. So the very first thing we do is we put it to a parking IP, because conveniently that'll come with the same IP address. So we move it to a temporary IP address. And then we push it a firmware and we push it a config. And then if anyone connects to that from their camp, they go through a captive portal process where we record basically their email address against their MAC address and then their physical street. The reason we do that is because a lot of times people will mount equipment and it will slowly degrade because they zip tied it to an RV, and it doesn't really necessarily handle the wind really well. So we want to be able to escalate to them. But this entire process is self-serve, where previously they would have to chase down some engineer and get configured, where now it's completely self-serve. Originally, one of the things that Ralph put together that was really awesome was the predecessor to this, where you would buy this equipment, you would come to center camp, and there was an Ethernet cable hanging outside of a shipping container. with a little monitor scrolling by. And so you basically brought your Ubiquiti station and you plugged it into this thing, and it would configure it for you, and then you brought it back to your camp, and you're ready to go. So we tried to move that forward with this auto provision methodology. A typical installation at a camp is what you would see on the right side there. So it's just a small nano bridge, and typically there's a small access point component to it. Getting a little bit more of a deep dive here on the equipment side, we use Dragon Wave links for a high-speed backbone. These are kind of the carrier-grade layer 2 bridges you would see a cellular company using to serve their cell site as their backhaul. These work really great. I was concerned that us installing and removing this every couple of years would cause a problem, but it's been very reliable. I think we're on our 3rd or 4th year using this equipment, so it works very well. The configuration it's not the easiest for these things. It's a little arcane, to say the least, but they work really well. On the distribution layer, it's Ubiquiti. It's hard to beat the price point. Ubiquiti is kind of like the choice of WISP, if you will. It's basically an Atheros or a Qualcomm-based chipset that they use, and then they add a little bit of software to effectively give it kind of a ghetto TDMA, where they can remove the hidden node problem somewhat, so they have a reservation system. And these radios are about $80, so they're very affordable. And on the routing and switching side, we ended up with Juniper, frankly, because at that time my day job had a good price with them, and then they also met our requirements of being fanless, an active PoE, and an operating system that allowed some level of automation, so it was pretty friendly to us at that point. Zooming in a little bit more on the physical topology here. So the backbone, again, is those Dragon Wave radios. Those are just layer 2 bridges. We place a router at all those locations. And so the main location in town is called Gerlach. That's the city of Gerlach. That's where our wireless ISP hands off. He stops at the town, and we have to do another 15 miles out to the playa. So we shoot to 2 different locations. One of them is at the NOC, the other is at the depot. The reason for that is timing. So the depot gets built as a staging or a logistics area for the Department of Public Works. So that tower gets installed almost immediately, and it's powered by a light tower. So before anyone camps out there, before there's a single building out there, there's a tower and internet. So that's really critical for them for logistics reasons. And then the NOC is kind of our central distribution point. We basically separate these out where departments typically connect to the depot and participants typically connect to the NOC. Again, some visuals here. So if you're afraid of heights, probably not the best team to volunteer for. We spend a lot of time on boom lifts, and it can be several hours of aiming and crimping cables and getting everything to work. Again, another close-up of one of the Dragon Wave radios. This is not like your mom's Wi-Fi setup at home. It's a little more complicated. You've got to have outdoor quality Ethernet. You have to have special Ethernet connectors that, of course, we lost, so we just have some electrical tape there. But we do treat it as a real network, so all of our trenches are flagged and marked, just like any other proper carrier. And again, another visual picture here. This is the depot, so it's just a small little shack with a tower. There's a router and a switch there, and then a server for some of our monitoring. You may notice, if you're looking at the PDF or a little bit closer, there's some lightning arresters also, so everything is protected from lightning events. So again, going back to that backbone picture where you saw the NOC and the depot, here they are represented with kind of the distribution layer. So you've got a couple routers located in them, and then various sectorized panel antennas, or sometimes an omni antenna. So what we do is we build these things called islands, and so an island is basically serving multiple departments with 2 different wireless links. So they connect to these 2 different redundant locations, and then we hand off a bunch of wired connections as best as we can. And we find that this is more efficient for a variety of reasons. One, it has kind of a shared faith, and it builds around some of the principles of Burning Man, which is when this thing loses power, a bunch of people get affected, and so they're motivated to fix that. Other reasons are for just redundancy and efficiency of the RF spectrum. If every department had their own RF radio, we would quickly overwhelm the access points. So we try to be as efficient as we can. And in some cases, we'll use like PoE extenders and whatnot to go beyond the standard limitations of copper Ethernet. The two differences here are there's 4 sector panels in the center camp NOC location. That's typically where camps or participants connect to. And then there's a single sector antenna and an omni at the depot. So slightly different ways of distributing content there. Again, close-up of lightning arresters. Like I said, there's not a lightning bar or a lightning arresting bar or any sort of grounding bar available for us. We literally have to get a post-hole digger and put the grounding rod, 8 feet in the ground ourselves, and then wire up all the lightning arresting. And it's also a 24/7 operation, so we're fully on call all the time. If there's a problem, we actually have a bucket truck in our department that we can operate if needed. Again, an island example here, so it's 2 of those same radios you saw, 2 of the nano bridges. Ubiquiti calls this the nano beams now. They have a slightly different product. And then you've got a demarcation of typically a switch or a router. Nice things about that particular product line is the configs are pretty much the same, whether it's what's a router or a switch. And for us, again, since we only do NAT, when we demarcate in Gerlach, these things are pretty much just routing. There's no NAT functionality required. Again, you'll see a close-up here. There's a fiber picture, or there's some fiber cables in this picture. That was an experiment that worked out really well until it was removed. Because the way that it was removed is that it goes along the same trenches as our power department. And the way they remove their cables is with a steel cable and a truck, and just rip it out. So this came back as about 16 other fiber cables after that, so it worked out so well. So automation, this is the hip buzzword these days. So originally we had a bunch of homegrown scripts. Originally Ralph had worked on representing the network as basically a CSV file that was fed into Nagios for generating the Nagios config, and he extended that. So it had Nagios things like X and Y coordinates for the map, but it also had parent-child relationships and IP schemes and that sort of thing. And we kind of built upon that. So one year we tried just kind of putting everything represented as a YAML file, and we built various scripts, one to generate forward DNS, and one for reverse DNS, and one for switch configs, and one for router configs, and that wasn't really scaling so well. So we ended up doing basically a bake-off, where we said, okay, it needs to be something that's open source and easy to use, and it needs to be something that can be embraced by the team, where we have different knowledge sets. So some of our team members have written RFCs, and some of them it's the first time they've crimped a cable. So it needs to be something that's usable by that diverse background. So we ended up using something called NCG. This is called the Network Configuration Generator. This has actually been presented at NANOG several years ago. So the gentleman who wrote this software, his playa name is Domo. He also wrote some software called Major Domo. And so he was fortunate enough to be a member of our team. So of course, if it's something that he wrote, then he's got to support it. So the principal developer put most of our configs and converted it into NGG format. And I would say that the learning curve was fairly steep initially, but as that presentation shows from NANOG 49, the workflow he preached is totally possible of essentially architects building a template or kind of a universal design, and then operators are not personnel kind of rinsing and repeating, filling out some variables and adding customers as needed. So it's totally possible. So the way we laid that out is there's basically 3 major input files. So you've got things like the site name, what type of hardware it is, does it have a static IP address, or is it just some like 1918 space? Things like what type of interface is it bound to? Because interfaces are a little bit different for us, right? If you're at an island, your demarcation is that routed port on that switch. But you may be a participant where you're going over some wireless infrastructure, so your demarcation is a layer 2 bridge in your camp. So there's a couple of different configurations that we offer. So again, these are flat files, and I put them in a table here to make them a little more legible. And then there's a VLANs file, so you've got a unique VLAN ID, again, a description, a category. We use a category for monitoring purposes. Who's using more bandwidth? Is it the participants, or is it the departments? Historically, it was the participants. This year, it was definitely the departments. So it's something that we use to break down monitoring data. Where that VLAN is plumbed to, and again, what type of configuration are we offering, and who's serving up DHCP. An interesting problem we found is that while the Juniper devices do support DHCP, when they receive a number of requests for DHCP, they just stop responding, and the process is still running. So that's kind of a bummer. So this basic field is where we can say, okay, we want to use a DHCP relay. The IP address is derived from the VLAN ID. So we'll use like the 3rd octet will be the 1918 space we would use for that particular VLAN segment. And then there's a static IP address or public routable IP address that we can override. So that's the last field that you see. NGG is built off of Ruby, so it uses standard ERB templates. If anyone's familiar with that, the templating language, this should look fairly familiar. So we've got basically a string completion. We've got something keyed off of the model number, and then an array where we're just looping as a key value. It gets a little more complicated very quickly here. So here we've got some DHCP where we're enumerating DHCP. So again, we're doing something like, if the VLAN ID, pull from the third octet, and then we know what the IP space is. If the DHCP source is set to gateway, then generate this config on this gateway. If it's set to DHCPD, then adjust it so that it's pointing to a DHCP relay server. So one of the things that's interesting about NCG is that some of the logic, or a lot of the logic, actually falls in the template itself. And again, we started initially with just doing routers and switches, but now we have this doing forward and reverse DNS, all of our wireless station and access point configs, smoke ping, RRD tool, pretty much everything. We don't configure anything by hand. Essentially, what the process is that you make the change, you check it into Git, whatever you've changed, and you type make deploy. So as you can see here, we've got 286 configs that come out of this. Again, this was crucial to be able to scale not only the network itself, but the teams, so that people could attend the event and not get very frustrated weeks before because they spent all their time configuring. There's a lot of other things that we need to accomplish before the event, and doing any sort of configuration by hand is not one of them. So what are some of the other lessons that we learned? 2.4, as I think a lot of the operators in this room will understand, is basically completely unusable. For us, people don't bring their shiniest, iPhone 6 to Burning Man, right? They bring their old Linksys or their old, virus-infested laptop, that sort of thing. So it's not always the best equipment they bring out there. So 2.4 is completely unusable for us. We haven't used that for several years now. Drones use that for video downlink. You see video cameras, that sort of thing. Another interesting thing is, again, because people bring older technology out there that's not necessarily patched up or has a previous configuration, is that we completely avoid 1918. We use an RFC called 6598, which is a /10 that's not allowed to be routed on the internet, and it's for service providers to use, and we are the service provider. And this actually is very useful. It gives us a lot more IP space, and it's very clear when a customer comes to us and says, hey, I'm having some problems with 192.168, we can just immediately walk away and say, that's not us, that's someone else. So it's a very nice, clear demarcation. As I mentioned earlier, we don't do any NAT on PLY anymore. NAT occurs in Gerlach, so the network is fully routed. On the personnel side, I think one of the lessons that we've really learned is that we're treating the network more as kind of like a software project, if you will. And so we're refactoring NCG and those configs every year to add more automation or streamline it and make it a more powerful tool for us. And in fact, we've gotten almost too efficient where in the last 2 years, they've actually now put us on call. So we get a pager at Burning Man, multiple pagers in fact, and we have an on-call rotation. There's a pager system there. So we've really made the network in some ways a little too efficient, where again, we're not spending time in that air-conditioned room, we're actually now able to attend the event. So going towards the future here, what are some of the improvements we'd like to do? The single point of failure problem is really difficult for us to solve. On Playa, the network's fairly redundant. We have multiple sites that people connect to. We have multiple sources of power. It's really been cleaned up with as much as we can at the event site. But we go back to this single point of failure in town to pick up our IP. And unfortunately, IP is quite expensive out there. In the rural parts of America, there are still places where it's $100 a megabit. In northern parts of Nevada, that's still the case. It's been that way for quite some time. And in fact, this is significantly cheaper than what the LEC was offering us. So our next provider choice is literally 108 miles away. So we're in the process of building some wireless links to reach these other providers because we want to have infrastructure that's as more redundant as possible. And so this is basically coordinating with 5 or 6 different agencies that own that mountaintop and putting power on it and getting a network plumbed back to Reno. So it's a huge undertaking. Something I've personally been working on for about 3 years now. It's not something that'll happen overnight. So it's very different than a data center that's a cross-connect away. Recently, there's a small exchange that started up in the Tahoe, Reno area called Tahoe IX. There are a few providers we'd love to see join, so we'll probably be connecting to that. And of course, for Martin Levy here, IPv6 is something that we're trying to take a little more seriously. So last year, we were able to use a tunnel from Hurricane Electric. At the time, our upstream was only single home to Sprint, and so the performance was less than optimal, I would say, from a tunneling perspective. That upstream provider has been educated, as in he gave me logins and I fixed his network. So his network now uses SSH and now runs BGP and OSPF and all that good stuff. So because of that, I have his Aaron login, or I'm actually one of his contacts, and so I applied for V6 and he took it seriously, and he's now dual stacked. So he's multi-homed to I believe Quest, Level 3, and Sprint, and so he's been really supportive of us. Even though he's a little expensive, he's our only choice, but he's been a real partner in increasing the network's capability. And again, down the road, we expected to reach capacity as more of these applications were more relevant to the organization. And this year was an interesting experience for us. We've had our own IP space from Aaron for 2 years, and we use that sparsely as we can. Not every iPhone, again, out in the playa needs a public IP address, but there are a lot of projects that do. A lot of folks that bring out database servers and other infrastructure that it's really helpful for them. But one of the things that's interesting is because we have our own IP space, we get our, I get the emails for the takedown notices and DMCA and that sort of thing. And so what's interesting for me is that, in the past we had 1 or 2 where we'd get a trickle of notifications of something was being downloaded, a Showtime or an HBO show or something like that. And that was typically during the event. But now we get that pre-event. We also get it for adult content. So whatever our users are doing, they're being well seen out there as downloading lots of content. And so capacity is a real big problem for us. It's not like we can just add more peering or add more transit or whatever. There's just none available within 100 miles. So it's a real problem for us to add capacity to the network, and it's something that we've been trying to improve upon. And this year was one of the first years where we actually had to strongly consider some sort of IDP or traffic shaping and saying, well, certain services would be blocked. There's no charge for the internet access for any of the departments. There's no bill back you'd see in a typical organization, and there's no charge to the participants. And so it's something that we have to figure out, how do we tackle this problem without blocking services that we just don't want to get into that game. The other thing is on the network automation side, I think automation is a really strong incentive to make your team and your product scale. And I wanted to spend a lot more time talking about that today. But I think the overall background and story was a little more interesting to folks. One of the things that we're working on is looking at tools like Ansible. Ansible is kind of interesting because it's very flexible in what the input data mechanism is. So I wrote a bunch of Python scripts that take the standard NCG input formats, convert it to YAML, and it just kind of works within Ansible's templating framework. So that's something that we're going to look at, because NCG has been really great for us, but there's literally one developer and one main user. We'd like to use some software that has a larger community as best as we can. And last useful slide here, again, kind of summarizing some of the lessons we learned over the 10 plus years that we've been doing this out in the desert, is again, automation is really key. Start with something simple, whether that's generating DNS configs or maybe it's just your switch configs. Pick something and start from there. You're never going to automate everything from day one. It's also important to visualize essentially what some of the other output mechanisms will be. Billing for us is not something that we do, but monitoring is something really useful. So that for us, that was kind of an afterthought, and so we added things like that category designation. Single source of truth is incredibly powerful. This is something from kind of the DevOps revolution that sysadmins had learned decades ago, but a lot of network engineers are still coming up to speed with this, is that you don't necessarily have to buy a super fancy IPAM management software, but floating around that Excel spreadsheet is not scalable. So for us, we put everything in Git, and what's great about Git is that it's a distributed offline database for us, right? So when we're doing a deployment, we've already have a checkout, we can make our changes, do our deployment, and then check back in when we have internet access again. So Git's been really great for us, but I think you need to pick the tool that's applicable to your organization for security needs, for auditing needs. Again, stress level, people have to learn a new tool. Everyone on our team already knew Git, so that wasn't a really big deal. And of course, budget. And then finally, change is really difficult for everyone, particularly volunteers that again, may not necessarily be focused and may be distracted for whatever reason because they want to go back to their camp and build their art piece, or they want to go see their friends. And so for us, we really focused on the physical layer and the personnel, the people layer. So we went to layer 1 and 8, and then we came to the middle. And I think that was really important because it solved a lot of problems where we organically built basically these products and services and the delivery, and processes became organic for us. It wasn't that a process was forced to us and we had to deal with it. And I think that was really important, particularly around volunteers getting some fun and excitement out of continuing to build this network. So finally, if there are any questions or comments, or anyone has a trenching machine they'd like to do some trenching, there's about a 60-mile gap that needs some fiber. I know exactly where it is. Oh, I see Anton's getting up, so I better have my qualm skills down.
Racing to the mic, Anton Capella, 5'9". Excellent presentation, Matt. Thanks for the summary. It was a good time reviewing it, too. I did have one question for you that I didn't see addressed here, and that is I've heard rumors, I guess, about folks bringing GSM or UMTS hardware or cellular infrastructure. Can you comment on that, or is that something your team does or knows about?
Yeah, thanks, Tony. I mean, that's a great example of a participant technology project. That's a group called OpenBTS, and so they have an open source GSM framework that ties into Asterix or other SIP servers. And they would actually come to Burning Man for QA. So what they do is they'd bring out their kind of homegrown GSM stations, and they use Burning Man for a DDoS, right? Because everyone has 70,000 phones to try to associate and register. So they actually use Burning Man for QA. They didn't return this year, but had been there the last, I think, 3 years prior to that. And Ralph partners with them pretty significantly, so I'm sure he'd be able to answer more questions about that.
Hi, Brian Fields. Well, Alcatel-Lucent, I guess, but just a general question here. Well, I guess first of all, are you guys a nonprofit organization?
Yeah, so Burning Man is an umbrella organization recently formed as a nonprofit. Traditionally, it was an LLC, and they're moving all the departments under the Burning Man Project, which is a nonprofit.
Okay, cool. This is actually very similar to some other stuff that I'm involved in, and some of the networks that we've built, mostly for amateur radio type use. I don't know if you're familiar with the HamWAN group out of Seattle. They're doing some stuff very, very similar to this. But I was going to ask, I know in that area and previously there's a couple rural cellular telephone companies that have a good amount of bandwidth out there. The one that comes to name is probably ComNet Wireless. Have you guys been able to get anything bandwidth-wise from them? Because I know they have a number of 6 gig hops out there that are OC3, if not greater than that.
Yeah, so this is something I have to be very, very clear about. So I'm a volunteer for Burning Man, and I'm engaged in a contract to operate this network for several weeks out of the year, but I'm not employed by Burning Man, the project of Burning Man LLC, so I wanted to state that. It's an interesting problem. So ComNet, as you do point out, is a cellular provider focused on rural agreements. So they basically put a cell site in a remote region, and then they have roaming agreements with T-Mobile, AT&T, Verizon, that sort of thing. The same provider that we buy our IP from is the same place they buy their backhaul from. So we're both in contention for the same backhaul connectivity. ComNet had a cell tower on site this year, and we were both fighting for that capacity. So great folks to work with, and we did a lot of frequency coordination with them. But unfortunately, we're still fighting that last 100 miles to solve that problem.
Okay, thanks. I'll have to find you and talk to you later.
Certainly.
All right, we got time for one more question down here.
Adam Thompson, Manitoba Internet Exchange. I'm just noticing with your pure layer 3 infrastructure, it's one of the few real-world deployments I've seen where ECMP is actually a possibility. Have you tried turning it on, and was there any point?
Well, we haven't turned off ECMP.
Okay. Do you actually see it working?
Yeah, yeah, definitely.
Okay.
Yeah, we typically will set a particular OSPF cost to preference a link just for administrative reasons. But yeah, it certainly works.
Okay, so it's not actually causing you any problems, and it is working as designed.
Yep.
Wow.
Great, thank you.